Hello, welcome back to our series of videos where we're making like a mini Rust in Rust. This is video 11. My name's Andy. Welcome. Surely this isn't your first video. It'd be weird to jump in at this point, but if it is, you're really welcome. You might want to start at the beginning. I don't know. It depends what exciting things are going to happen in this video. But yeah, just really welcome you. If you're understanding everything that's going on, you're really welcome. If I'm doing it all wrong, let me know as kindly as you can in the comments. If none of this makes any sense to you, you're still welcome to enjoy this for whatever you get out of it. And you're also welcome to ask questions about it and stuff like that. So just like try and enjoy it, right? This is supposed to be fun. That's why I'm doing it. I'm doing it because it's fun for me, and I'm doing it because I'm hoping it's fun for you. So what we are at the moment is we're trying to make this language, and we've got expressions like this working, like not only breaking this up into separate symbols, which is called lexing, and creating like a tree shape out of it to say, look, this is a plus with two bits to it, a left and a right. That's parsing, but also actually evaluating these numbers, turning them into numbers, adding them up, and getting the answer out, which is 100. So that stuff's already working. What we're trying to get to, and we've got this guiding test which is currently failing, is we want to be able to say things like let x equal 3, and then evaluate what happens when you add 4 to x. The answer should come out as 7. So we're a way away from actually having that work at the moment. But what we did manage to do last time is the lexing part. So we wrote a test identical to this, but for lexing, in our lexing place, it looks like this. And we're basically saying if you lex this thing, you get these tokens out. And the tokens are the let keyword, which is a keyword, the x symbol, and then an equal sign, an int, which is 3, semicolon to say it's the end of a statement, and then the symbol x again, an operator plus, number 4. So basically you break up all this stuff, each of these chunks, into these tokens. Now that we've got that, we want to be able to parse it, and we want to say what parsed structure we'll get out of this input code. So what we haven't got a parsing test yet. We've got an evaluating test, which we're ignoring because it's currently too difficult for us. It's failing. But now let's do something in the parsing world, which what we'll do is we'll put it just before the error message bits. We won't ignore it because we're going to hopefully get it parsing fairly soon. We might need some smaller ones first, but we'll see. And this is going to be parse this thing, and the answer is going to be, well, we need to think about this a bit, but it's going to be some kind of syntax tree, definitely. Multiple syntax. Well, now hold on. What is it? Yeah, it's going to be a statement. I think it's going to be a statement because the semicolon at the end means it's a statement. So I think it's going to need to be a statement that contains an assignment. And the assignment is the assignment really only has 2 bits to it, right? So an assignment statement basically is a let statement. Assignment is what we call a let statement. Tell you what, I've realized I forgot to do something, so I'm just going to write it down before I forget. To do, rename symbol to identifier, because that's what Rust calls it. All right, so just so I don't forget that. All right, now back to what we're doing. So it should be an assignment, because that's what we call a let statement. And the left-hand side of the assignment should be a leaf, I guess. Or should it just be a symbol token? I think we might need a new type of thing, a new type of token, like subset of token. You know, we have these subsets of token. I think maybe it should be a symbol token. Where the symbol that it contains is X, I'm not sure about this. We might need to mess with this. And the position of x is 1, 2, 3, 4, comma 1. But yeah, an assignment is going to consist of a symbol token. So let's say net assignment has named parts to it. So it's going to have like the symbol or identifier, I guess. It's going to be this new thing we're inventing called a symbol token. And the right-hand side, which we could call expression, or we could call not sure, but anyway, it's going to be an expression, which could be like that. An expression is, in this case, it's going to contain an operate. No, it's going to, sorry, just looking at the 3 now. So this 3 is actually an expression, but it's a very simple expression. It just consists of I think I need to wrap all these things up in leaf. So I think I should be saying here, symbol is, no. Oh, yeah, well, we'll see. This expression consists of a leaf, which consists of a leaf token of type int, where there's just a literal 3, and the position in the code of that 3 is 8, and it's 1 long. I think that's it. So that is our first syntax tree. And then after the semicolon, there's another one, which is simpler. That is going to be, I don't know how this expression, I mean, it's definitely an operation where the operator is plus. So this will be, is it an operator token kind plus, yeah? With the plus inside it. And that's plus, no, hang on, what is the position of, yeah, it's the position of the plus. So the plus is at 8, 9, 10, 11, 12, 13, 14, and it's 1 long. And then the left-hand side and the right-hand side of this operation are syntax tree leaf, which is a leaf token with a leaf token kind. There's a lot of types going on here, aren't there? But that's the Rust way. You end up with a lot of types, and that is at 12, and it's 1 long. Oh, it's not happy. Why are you not happy? Oh, it should be a box. We might need more boxes. There's going to be more potentially recursive stuff. And then we're going to have something very similar, but instead of it being a symbol, the right-hand side of this is a int with a 4 in it. And these are owned strings. I don't think I made some helpful functions for leaf token kind, did I? Oh, I did. For int I did, but not for symbol. So that's good. Let's do it. Let's make nice, convenient functions, and I guess for plus as well. I either want to make one or there already is one. Oh, it's not happy about int, which I thought I just saw that there was an int one. No, it's leaf token int. Oh, so okay, so I'm making my life more difficult than it should be leaf token int, pass in the 4, pass in the 12,1, and it does all the work of all this stuff for us. So similarly, this is going to be leaf token symbol. We haven't written this yet, but we're about to. Oh, one of these is wrong. That should be 16.1, right? And this one actually is 12.1. And again, this is going to be a plus, and the position is 14.1. So this is just some convenience functions to make an operator token and a leaf token, and we need another convenience function to make a symbol leaf token. So let's do that now. So this is letting us make a leaf token of type symbol in just a slightly quicker way. That's all that's doing. Whoops. So these two bits were quite easy. This operation is we've already parsed stuff like that before. Although I wasn't sure. Yeah, no, look, here's an operation. Yeah. And it does make a syntax tree leaf for each side. So we are at least right about that bit for now. So I guess this test that we're making is a little overcomplicated, because actually the bit that's not yet tested yet is this assignment. So I could make a mini test that just tests that bit, and I think I will. Oh, and also that name is not right, isn't it? It should say. So let's just say an assignment. But I guess it's just parse assignment. Parse assignment. We'll lose the semicolon for now. And that's going to make our lives easier. We'll sort out the rest of this test in a minute. And then this is parse assignment. I mean, the reason we've got this test here and usage is, the reason we've got this is just to exactly match what we've got in other code. So it's a slightly contrived example for parsing, but I just want to make sure the exact same program is being tested in the lexing, parsing and evaluating stage, just because that feels right to me. Now, when we parse just let x equal 3 with no semicolon, it's no longer a statement. It's just an assignment. I think if this parsing is going to work out the way I think it's going to, where we hit the semicolon, it's like, okay, wrap what you've got now up and call that a statement. So now we can just comment out our more difficult test for a second, and just focus on making this test compile and then pass. So first of all, syntax tree doesn't have an assignment thing inside it yet, variant, but we're going to need one. So an assignment is a let blah equal blah. So the let and the equal were just not important, but the left-hand side, which I think we called symbol, I think we invented a symbol token as a thing to go there, did we? And then expression is going to be a box of syntax tree, right? Similar to an operation where you do plus and then left-hand side and right-hand side. This is going to be something equals and then the right-hand side. So we could call this right, because it's kind of the right-hand side of the equal sign, but I think expression makes it clear what it is. And did I say that we wanted a symbol token? I did. And it's still making sense to me. So there should be something here called a symbol token. But I think it's going to be a bit easier than these others, because it doesn't have types really. It doesn't have a kind of any kind. It's just, it's going to have a span. It's going to have a span. So it is actually going to have some stuff inside it. But it's essentially going to be symbol, which I think is going to be a string. Does leaf token kind of just have a string inside it? Yeah. I think it's going to be a string. No, that's not how you write that. It's like this. And it's going to have a span like everything else. Really wish I'd somehow type deft or made a type for this span, or maybe use the type that we already have in Miette. I don't know. Maybe we'll fix that sometime. So let's make sure that this is debug printable and comparable. or rather either checking whether they're equalable. Now what's it complaining about? Yeah, I've written this wrong. This should be, what did I say? Symbol colon x dot toOwned and span colon blah. Is that going to be good enough? Okay, it seems happy. And there's another thing here, which is an expression. I'm not sure this is right. Like, we don't have an expression here. We just said it's a leaf. So I think maybe in this case, maybe we'll need more later, but maybe we just need to say it's a leaf. And it should be a box of syntax tree. Because we had to have a box because, as we discussed last time, where is the type for this? No, not there. I'm looking for assignment, yeah. If we had a syntax tree inside here, then that would be a syntax tree that lives inside a syntax tree. So how is the compiler supposed to know what size that is? Because if it's a syntax tree inside a syntax tree inside a syntax tree going on forever, it could be infinite size. So it doesn't make sense. So instead of that, we wrap it in a box, and that means instead of syntax tree containing another syntax tree contains a pointer to another syntax tree, and we know exactly what size a pointer is, so it's fine. All right, so we've made some new types. Basically, the thing that we've added is whenever we hit, whenever we're trying to evaluate a syntax tree, there's this new thing called an assignment, and we don't know how to evaluate it yet. So I'm just going to crash when that happens for now by hitting this to do. I probably don't need to worry about the warnings yet. Let's see the test fail. And the test fails because when we try and parse let x equal 3, we get to the let keyword and we don't have any parsing rules for what to do with the let keyword. And like I said at the end of the last video, parsing an assignment statement should be pretty straightforward because it's unambiguous. When we get in a let token, we definitely are going to have an assignment statement. So let's look at parsing. So we get hold of a token, and we find the next thing, and it's a token. And if it's a keyword, we want to do something, otherwise I want to do something else. So yeah, so we're basically handling everything. Okay, so what we're doing is checking whether this is a leaf, and otherwise failing. So I guess we want to do more than just, if it wasn't a leaf token, then there's still stuff we might want to do with this. So this try from feels a bit weird here. But I guess it's okay. But it does mean, all right, if it was a leaf token, then we get on with our either a leaf or some operation because there's a plus after that leaf token. In this case, let's go with this, and then if we can find a way to make this nicer, we will do it. But for now, there was an error finding a leaf token, so like converting that token into a leaf token. So it's not a leaf. So it's either something we don't know about, or it's something useful. And the useful thing we're trying to add is it might be a let keyword. So I guess we could do something like keyword token. This doesn't, I'm not comfortable with how this is working out, but I guess we can write this code and then we can refactor it to be nicer, right? So let's just say, try and make it into a keyword token. If that worked, do something. Otherwise, do something very similar to what we've already got. So, what have I... Oh, I'm missing a curly bracket, I guess. No? Yes. There we go. All right, so now I've got my code formatted. I feel better about things. So, yeah, currently we don't have a way of asking, is this token a keyword token? We do have something, right? What did we write? We wrote a thing that can convert the lex. When we lex, hang on, what happens? When we lex, we get out a token of type keyword. All right, so yeah, we don't need this. What we need is we just need to match on the token. I feel like maybe this should come before the thing where we try and turn it into a leaf or something like that. But if we match on the token, there's all kinds of let's just comment this out for a second. There's all kinds of token that there might be. So hang on, what is token? Oh, no, we want to match on token kind. Because a token is a struct and we want to match on this enum. There we go, that's more like it. So there are some types of token, some kinds of token, let's say, which we immediately know how to deal with. And in particular, there is this one that we're trying to handle, which is a keyword which contains a keyword of let, like so. And we're going to do something specific with let, which is like parse it as an assignment. We'll just take a reference to that there. And this is all bad because we should be doing this at the top level, I think. So basically, we get hold of a token, and if it's a keyword, then, or rather, if it's the let keyword specifically, then we know what to do. We're going to do some kind of thing which we're going to call assignment, I guess. We know it's an assignment. We don't even need the let keyword that we matched. Oh, maybe we need it because we need the position of that assignment statement. So that's interesting. But anyway, otherwise, if it's not a let keyword, we don't know what to do with it. But one possibility is that it is just a leaf. So we're going to handle that here. I guess any other keyword. Well, there aren't any other keywords, so we won't worry about that for now. Yeah, so anything else, we're going to do what we used to do before, which is, I guess this should be sum. We'll wrap this in sum. We haven't written the assignment function yet, so we're not sure whether it returns option, but I think probably not. I think it probably just returns result. And now this stuff can probably be done. I've messed all this up, but yeah, basically we'll go back to how we were to say, okay, it's not a keyword. What are we up to? That looks right. But we're missing... Yeah, this is just in the wrong place. So let's try putting it in the right place to see if it just somehow works. Let's line it up ourselves and try and understand what we've got wrong. Oh, it's a mess. It's a mess because this needs to be its own function or something. I can't read this code. So let's make it into its own function. So it's either going to be an assignment or it's going to be like, I guess, a leaf, I guess. So let's put this in a function called leaf, which we'll like figure out the right shape of it in a minute. And we'll just say self dot leaf. Now this might return none, I think. No, it won't. It's always going to be a leaf, or we're going to hit some kind of error. So basically what we're saying is the first token that we hit when we're parsing is either a let keyword to say we're about to start an assignment thing, and the only other thing we can handle at the moment is that it's some kind of leaf, like just a number or something like that, and that leaf might or might not be followed by an operation. So we shouldn't call this leaf, we should call this, it's leaf or operation or something we don't recognize, isn't it? So I've already got something called leaf or operation. And this, yeah. So there's some logic to having this at the top level. But it's too much. So we're just going to call it, we'll think of a better name if we get to it, but it's leaf or operation or unrecognized. And then this is going to break up into two parts, which is either the leaf or operation or the unrecognized, right? So it's going to make sense. But we have too many curly brackets somehow. So unexpected token. That's all fine. This curly bracket shouldn't be there. Is that right? This is not right. That's probably what's confusing us mostly. This should be take a mutable reference to self, and does it need to take anything else? Maybe not. And it should be returning the same as this stuff here, except without the option we think. We'll see whether we're right or not. Oh, I've done something to the cases. I pressed some key I didn't mean to press. I pressed U or L. No, Shift U, I guess, for like the opposite of uppercase. Now that token needs passing through. So that is going to be, token is a token, I think. All right, that's looking good. So let's break this apart a bit. So either this is a leaf. So let's just say this is a leaf. Or we don't know how to handle a non-leaf here. And now we had some example in other things. We had examples of things we might get. So it might be, e.g., starting an expression with plus would be an example of where when we get to here, it's like, hang on, I just can't deal with this token here. I'm not writing Lisp. Can't start expressions with pluses. All right, so we haven't written the actual code that we're trying to write this time, which is this assignment function, which is the thing that parses an assignment. And now I'm saying parse, I actually mean parse. I was saying parse all through the last video when I meant lex. But yes, so we've got a mutable reference to self. And we don't need the token passed in, we don't think, although we can change our mind about that if we want to. And we are going to return a result. And it is going to be a result of syntax tree because that's the only thing we can return from parsing. And it could fail because we've got quite a lot to do here. We've already seen that there's a let keyword, but now there's 3 more things we need. So we need the left-hand side, or what we called symbol, equals self.parse. Well, is it parse next or is it something else? We're going to go for parse next. Really, we just want one more token. For now, at least, the left-hand side of an assignment is just a single token. So we're just going to ask for it. And it might be none. We can't just question mark that here because it's an error. If we hit the end of the file, that's an error. So I guess it's going to be a let else. So we're going to say let the symbol be if tokens returns a sum, then that's all good. If it doesn't, we need to return some kind of error, which is unexpected end of file, I guess. Like so. But is unexpected end of file, is that a parsing failure, or is that only did we only have unexpected end of file defined in the lexing world? No, parsing has an unexpected end of file, so we're okay. So source is always the same thing. It's just self.file contents. So that's just like what source code are we in generally, and then the label is, what is label? Where's our example of using this? Oh yeah, it's like, oh hold on, source, it should look like this. I was talking rubbish. It's not just file.contents, it's this thing. And the label should be something, some kind of, we need a span from somewhere. There should be an error. Like that. But what's the problem? Oh, we need to into it to turn it into the meet thing. Hang on, what am I doing wrong? We did this down the bottom here. Oh, I think the bracket's in the wrong place. Yeah. And the only thing only problem we've got now is this error. We need something that's got a span in it. So I guess this token. So I guess we want to say, we do want to pass in the token just so we can use it for our span to say where in the code this went wrong. So we're going to say, please pass me in your token. Just so that if something goes wrong, we can say the place in the code it went wrong is around about where this token is. It's actually like slightly after this token because it's the end of the file immediately afterwards. But that's probably what we found before, is that was good enough. All right. So we've got hold of a symbol. Now we need to say the next thing should be an equal sign. So equals self.tokens.next. Else again, because like this has got to exist as well. And if we don't find an equals sign, it's the same again. Except this time the symbol is the closest to the end of the file that we're going to get. So again, it would be nice if instead of unexpected EOF we said expected something. So here we could say like expected equals sign. So let's to do this. To do expected. So we could say like, look, I expected this particular symbol and didn't get it. And here we might want to say something like expected a symbol, which we're going to rename to identifier, but we haven't yet. So we're going to do a big search and replace for that. All right. So now we've got hold of the equals sign, which again is just going to be a single token. It's got to be equals. So we actually can now do an assertion and say if if equals is a token, well, if the kind of equals is not a equals, so if it is an equals, so let's do equals dot kind. If it's not an equal sign, if it is an equal sign, then we need to check. Well, no, if it is, we're fine. But if it's not, so I guess we're going to say, we're going to do some kind of if not matches. If not matches, token kind equals, equals dot kind. I think, have we got access to the matches? Macro doesn't look like it. What's wrong? Oh, yeah, that should be have an exclamation mark for a start. Right, then. Hey, look, it's saying unexpected token in input. So this is a little bit like the kind of errors we print. But I think it's because, what does the matches macro do? Maybe I've got it the wrong way round. Maybe it should be, yeah, all right. It should be the other way around. It should be equals dot kind. So basically, if equals dot kind is not an equals, then we should return some kind of error. Similar to this. And again, it should be, I expected an equals sign, but I got something else. But found whatever token is. Now, why is it complaining? Oh yeah, it's because we haven't finished this function yet because we're not returning a syntax tree. So I guess we also want to check, can we shut up this error by doing something like, okay, syntax tree. Is it going to be an assignment? The symbol is going to be, what is symbol? It's a symbol token. So I guess soon we're going to turn symbol into a symbol token. We haven't done expression yet. We'll do that next. So oh, this is our problem. Thank you, compiler error. Right, so we need to find a symbol and then an equals sign. We check that the equal sign really is an equal sign. What we haven't done is check that the symbol really is a symbol. So what we need to do now is say let symbol token. What is this? How do we make this? I guess it should be let symbol, let. Do we have a way of making a symbol token from a symbol? I feel like maybe we what did we write? Do we have any kind of symbol token yet? I just do not remember things very well. Well, we must have defined a symbol token somewhere because we're naming it in assignment. So let's have a look at assignment and see what it says. It says there's a thing called symbol token. Oh yeah, it's defined. Oh, I thought it would be in lexed, but of course these specific token types are actually defined in the parser because it's the parser that cares about them. So this thing doesn't actually yet know how to make one of itself. So when what we've written for leaf token is a way of making a leaf token from a token. So we need something similar here for making a symbol token from a token. We're going to have our own special error type again called not symbol token. And we'll just copy not leaf token and see how that looks. I think it's very simple. Yeah, holds onto a span, which we're probably going to need here. So try from token for symbol token. If I can type that. And this is going to be not symbol token. So basically, there's a way of trying to make a symbol token from a token. And it's only going to work on a token which is of type no, it should be token.kind, right? It's only going to work on a token that is of type symbol. Otherwise, we're going to have some kind of failure here. Well, we know what kind. It's going to be exactly a not symbol token, where the span is a span of value. So the only thing that this won't work is if it's a symbol which has a string in it, then it's going to be a symbol token. It's going to be OK of a symbol token with the symbol s and the span of value.span. So basically, oh come on. Basically, this is a way of saying, I've got a token, I want you to give me a symbol token, but it might go wrong because it might not be a symbol token. So now we've defined that, we can use it in our code here by saying, look, we've got a token. We know we found a token, but it needs to be the right type. So we can say let symbol equals symbol token try from symbol, else return some kind of error. So this is expected a symbol got end of file, and this is expected a symbol got whatever symbol is. So this will, instead of unexpected eof, this is like something, and this is also not unexpected eof. This is unexpected token, I guess. We're going to make these errors better later. But this should be, just for completeness, it should be token that's now, a symbol has now got hold of that span, so we can provide it here. All right, so get me a token. If there isn't one, fail. If there is one, check it's a symbol token. If it isn't, fail. Get me an equals. If there isn't one, fail. Let's put a new line in to match. If it wasn't an equals, fail. No, here. If it wasn't an equals, fail. So we're doing the matches manually here, whereas we're kind of doing the same type of stuff, but inside this try from function here. So we could have like an equals token that works similarly, but I think just checking that it's an equals here is fine, because we don't then do anything with it after that. We don't need to remember that it was an equals. It's just like it wasn't it was a malformed expression if it wasn't an equals. So the last thing we need to do is get hold of the expression which follows the equals, the right hand side of the assignment statement. So it's going to be self dot parse next, right? Basically the next expression that we're looking for is going to be an expression. Now the only thing is that this might be none. So we need to say let some expression equal parse next, and if it's not if it's none, again, we need to fail. And again, it's an unexpected end of file. Oh, it's not really, it might not be an end of file. That's interesting. It's an unexpected end of expression. So let's just say, selected expression on right hand side of equals, but also to do this and above eof errors may not be end of file, might be end of, oh no, the others are end of file because we're just getting a token, but this one, so this may not be end of file, might be end of, like, e.g. brackets, so we need to handle that in some way. Okay, we'll allow that to get onto our last column. So this shouldn't be unexpected end of file. It should be, in fact, let's do it now. This should be unexpected end. So it's just like expression ended. It's like missing expression. Should we go for missing expression? Like that. So basically, we tried to get another token. Another expression by parsing stuff. And there has to be one there. There has to be some kind of right-hand side to this assignment statement. But there wasn't for some reason because we got back a none. So we're failing with a missing expression. Otherwise, we have a syntax tree. But parsing, of course, may return an error. So I guess we can question mark this expression. And like basically, if we fail to parse the sub expression, well then return. And this should be a box, I think. No, we should be wrap this up in a box like this, I think. Something like that. Well, obviously, that's not how you write that. You have to say expression like that. All right, so this error type doesn't exist, so let's make it missing expression. It's very much like an unexpected end of file, except it's an unexpected end of expression. Missing expression. I don't know how to say that in a better way. Reached end of... I mean, it's just like expected an expression here. Something like that. Again, we're going to try this out with the Rust compiler, see what the Rust compiler says, because it has really good error messages, and we're going to try and produce something as nice. All right, so what else have we got? So the problem is we tried to get, so what, can we just nick it out of token instead? No. We need to get it out of, we need to match on this and get it out of the error half of this. It's a similar problem we had last time. So we need to match on trying to get the symbol token out of the token. And then we've got cases of everything's okay. In which case, no, not semicolon there. So all of this is trying to get symbol out. And if it all was a fine, we're just going to return symbol. And if it was an error, we got an E. And that the whole point of restructuring it like this is that now we've got an E, we can return an error. And use E's span. And now we don't need this stuff. Something like that. I feel like we need a question mark or something to make this nicer. No, all right, the compiler is letting us do this. So it knows that this side of the expression never and never resolves to a value because it returns. So I guess we're okay. And the type of it is symbol token, which is exactly what we're looking for. So it's okay. Now we're being warned about something. Symbol is never being used. Why not? Interesting. Should we delete it? See what happens? Maybe we ended up not needing that thing, or maybe we're going to regret that and need to put it back in a second. All right, so it looks to me like lexing assignment statement passed. Wow, that's amazing. So let's just go look at that test, check it's really what it's supposed to be. Yeah, so when we parse this assignment, we get this assignment out of it. So the last little bit we need to do is recognize a statement on top of that. So let's re-enable our bigger test. And what this says is all of this, this assignment is great. We can parse it. But then if there's a semicolon after it, then it should be a statement. And yeah, we wrote this wrong when we did it. So let's fix that part first. So symbol will be X and span will be 4.1. All this stuff we can reuse. It's all fine. This, we realized we didn't need an expression wrapping this. It's just a syntax tree of type leaf. And in fact, it's a box of syntax tree of type leaf, which we construct here. Oh, and here, look, was where we were using leaf token symbol. So what did we do? Oh, so we did regret it indeed. This should be, well, I guess we should be having a constructor on symbol token called new, let's say, which takes in an X and a 4.1. And we'll write that new function in a second. And we don't have a statement yet because we haven't done it. So yeah, leaf token symbol. Unfortunately, we're going to have to put right back after we just deleted it. And I can't undo because I've done a million things since then. So let's put symbol back in. I think it's pretty straightforward, right? It's just, we want to be able to create. I kind of wonder, why have we not had this before? When we were parsing like x plus 3 earlier, should we not have had leaf token symbol? Let's see. When did we parse this thing? Oh no, we haven't done parsing. We haven't done parsing of symbols. Okay, we better do that. So let's comment this back out. Parse the symbols. And then we should, yeah, so we jumped ahead. So parsing a symbol produces, it also is going to produce a leaf expression. Let's go for foo. That's a classic. Symbol. And while we're here, we should also be able to parse symbols in operators. So parsing a sum of symbols. And we'll put symbols in both positions and see whether that works. So this should be foo plus bar. And these should be leaves, but they should be leaves with symbol nodes inside them. So notice, and I'm not sure how this is going to work out, but notice that a symbol might end up being a leaf token of type symbol, or it might end up being a symbol token, depending on where in the parse tree we find it. Because on the left-hand side of an assignment, it can't be just any syntax tree, at least not for the moment, because we're not doing matching and stuff like that. It has to be exactly a symbol. So we've got this special type called a symbol token that represents the fact that it is just a symbol, whereas here, this could be any syntax tree, and it happens to be a leaf syntax tree with a symbol in it. All right, so this is going to be 0, 3, and this is going to be 1, 2, 3, 4, 5, 6, and also length 3. And this one, while we're at it, yeah, it's going to be 0, 3. We've done that already. Okay, so come on, they're going to pass. The right hand side is an int foo, so we've done something wrong here. I think what we've done is, oh yeah, it's just our test code. We didn't finish off this. This should be when we call the symbol function to make a symbol, it should make a symbol, not an int. So how about now? Okay. Parsing a sum of symbols produces an operator expression. So this is the second test that we were just making, and it should produce an operation with a plus from 4 to 1. Oh, I've said from 3 to 1. It should be from 4 to 1. I think it's just stuff like that we're falling down on. That should be from 4 to 1. And maybe the rest is right. Yeah. All right. So we're now able to parse expressions like this, a variable plus a variable, into this same kind of operation tree that we had before. And we can re-enable our test. And this is going to be the video if we get this parsing. We'll be able to parse an assignment and a addition coming after it, which would be really cool. So first of all, we've got to be able to create a new symbol token in this convenient fashion. So that's pretty straightforward. We're just going to import symbol token and add a little new function. This is just a convenience function. There's nothing clever about this at all. Like so. And we're going to take in a symbol, which will be an ampersand stro, which is really the convenience we need. Just the fact that we don't have to do a to-owned in our test code. We have to do it here instead. Take in a usize, comma usize. And it's going to return symbol, which just turns the symbol we were given into a string. And span is just going to be span. And this is probably only used in test, at least for the moment. So that was the easy bit. The hard bit is recognizing statements. So how is this going to work? We're going to, first of all, we just need to provide this thing called a statement. And it's just going to contain, I think, any syntax tree. Basically any expression. A statement is basically an expression followed by a semicolon. At least that's what I'm going with right now. We'll see if I'm right about that. Alright, so now we have to handle statements in various places, like here. And like at the moment, evaluating a statement is going to crash because we're not doing evaluation yet. And this should be a box. Like so. And we got a warning saying statements are not used yet. So now our test is that we're able to state our test, which is this thing should turn into a statement and it should fail. Because instead of that working, we get to the semicolon and it's like, don't know what I'm doing. So we need to do quite a few clever things now to make this work. We need to stop looking for a plus after this 3, because currently we've got let x equal 3, and now we're looking for an expression, and we're saying, well, maybe the thing after this is a plus, but it's not. So we want to say, okay, this 3 expression has ended, and I think that might already work. Let's have a look at how that works. So when we're parsing a, where is it? Yeah, we're still in parser. Gosh, this file's getting big. We need to sort this out. I'm getting lost in it. Right, so when we're parsing, we get hold of a token. It's not a let, right? It's a 3. So we go into the leaf or operation or unrecognized function, and we say, is it a leaf? And yes, it is a leaf. So we go into the leaf or operation function, and here's where we might be expecting a plus. So basically, we get hold of tokens. If there are no tokens, then we're fine. And if there's an operator, we're fine. If there's not an operator, we don't know what we're doing. So here it's like 3 semicolon, right? So there's 2 ways of handling this. We can either say, if we hit a semicolon, break out of here. Or I think what we want to do is say, when we call this, we want to say, if you hit a semicolon, stop. I think, and just treat it as if we reach the end. And it's even worse than that, because we also need to reuse that semicolon for something. So we might need to do some kind of backtracking. So how are we going to hack around this so that we don't have to solve all of these problems right away? I think we're going to have to peek. Or can we do something clever? Or have we done enough? It might be that we've done enough. Like, I think the next bit is going to need a little bit of thinking about what a parser really is. And at the moment, we've been kind of glossing over the fact that you need to know when to stop parsing an expression. Like, for example, if you're in a bracketed expression, you hit a close bracket. Well, that means you got to stop parsing the stuff that's inside that bracket. And here, we're inside a potential statement, right? We're parsing an expression, but it might be part of a statement. So we need to be able to say, okay, if you hit a semicolon, your expression is over. So we need those 2 things. Number 1, stop parsing if you hit a semicolon. And number 2, also, please give me that semicolon, even though you've already pulled it out of the list of tokens. I still need it because I'm going to use it to figure out that I'm in a statement. So we're actually going to need some kind of thing. It's going to look like, maybe we can map it out. It's going to look like we were passed in. So where are we at? Let's do a commit. Let's get our test passing and do a commit. So the test that's failing is our guiding test in the parser world. Where are we? This one. So can we ignore? I think we can ignore this and say it needs backtracking or peeking, and you have finished when you hit X. And let's just try and fit that on one line. So basically, this is what the next video is going to be about, is like some of this backtracking or peeking and saying when we're going to finish. So ignore it. All our tests pass, make a commit, which is basically lexing and parsing assignment expressions, because they're really not assignment statements until we've done the bit we're doing now. Of course, assignment expressions are weird because assignments don't return, in Rust, assignments don't return value. So that it is an expression, as in it's not a statement, but it returns the unit type, which is a bit odd. But that's, anyway, doesn't matter. Right, so we've done a commit. Now let's do a little bit of mapping out of what this is going to look like. So when we're doing this leave for operation, we're going to pass in some kind of stop if, I guess, stop tokens, something like this, which is going to be a vec of token kind, I think. Stop. What should we call this? End markers, maybe. Like, it's just like basically stop parsing if you hit one of these kinds of token. And it's going to be if token.kind. It basically, if this kind is not in, or we can just say if it is in. Let's just say that if end markers contains token.kind, then return something. What are we returning? Something. What do we return if it all goes wrong? We just return the leaf token we were passed in. Yeah. So it's going to be the same thing. Now, can we get away without an early return? We could do so with a little bit more nesting. Should be a reference to a token, like so. What do we think about the early return? Otherwise, we're going to go one further nesting in, but it will make more sense, I think. But then we'll need a return in here if we do the fall through. Fine, we'll have it like this for now. We're just doing example code, Andy. Why am I stressing about this? So let's just say something about this. We reached an end marker. Stop parsing this expression. But before we do that, we also want to do, so not just stop parsing this expression, but also return the token we pulled to the list and stop parsing. So this is trying to express the fact that what we want to do, like, I don't know if this is the right, I was thinking about this and saying something like return or push or something. Oh, we can't use return because that's a keyword. I was talking about that earlier. You can't use a keyword as an identifier. Push. Is it just push? What is tokens? At the moment, tokens is something that implements iterator. So we're going to need something cleverer than iterator. But I was thinking about, like, a lot of these things implement stuff by peaking. So that's peaking is a way of asking an iterator, can you tell me the next thing without actually removing it from the list? And that feels a little bit unnatural to me. What I want to do is pull it off the list, but then if I realize I didn't need it, push it back on. And I think that's going to fit better how we use stuff here. So we're going to try that out and see how it goes. I don't like push because it's so common, like vecs can be pushed. But on the other hand, it does, like when you push onto a vec, it does kind of mean this, like you're putting it back onto the front in some sense. We could call it push front, or we could say like give back. So well, let's try to think about, well, maybe we can think about the name in the next video, but it's got to be kind of the opposite of next in some sense. It's like unnext, right? It's like give you back a thing you just gave me, and then the next time we call next, we're going to give it back again. So what we're going to give back is token. Yeah. And that, I think, basically covers it. If we allow passing in an end marker into this thing, and in this case the end marker is going to be a semicolon, will mean that we've reached the end of our thing, and then we can push that semicolon back into our iterator of tokens, then the next time around the loop, you know what, this isn't quite right in this case, because this semicolon is not, so we are going to need this stuff, but actually to turn an expression into a statement, it's not going to need either of these things, I think, because a semicolon is like an operator that happens after an expression to turn it into a statement. So, yeah, how interesting. So can we fix that now? That would be interesting. So instead of all this, it's going to be just check, first of all, check whether it is a semicolon. If it's a semicolon, I guess it's going to be that. Then we do something. Otherwise, we carry on. So what we do is we return. So this is a turn up. I was not expecting this. But I think we don't need to do the clever stuff quite yet. But we're definitely going to need that stuff I was just describing soon. So it's going to be a syntax tree statement just containing leaf token. No, it's not. It doesn't just contain leaf token. Yeah, the problem is yeah, okay. So we do need to be clever. No, we can't do it in here. So it's not leaf or operation. It's not this thing, this leaf token that we've been dealing with that's going to get turned into a statement or wrapped up in a statement. It's the whole assignment that's going to get wrapped up in a statement. So actually it's not going to happen here. It's at the higher level, which is basically, we're going to tell it, like I said, I think we're going to tell it, we are going to pass in a list of things. So let's put it back. Can we put it back? Did I lose it? Or is it? No, it's there. Yeah. Yeah. So we are going to push this thing back into the list and say, we've finished parsing this expression, this leaf token thing, because we hit something that's like outside of our scope, which is this semicolon. And then at the higher level, when we're trying to parse an expression, which is basically here, then once we've found an assignment, it's not finished. So it's going to be assignment or statement or something like that. And then after we've finished parsing an assignment, instead of just saying, oh, we've stopped now because we've hit an expression, we're going to need to say, but if there's a semicolon after it, wrap up the thing you just made, which in this case is an assignment, as a statement. So in a way, instead of calling assignment here, yeah, I think actually we need to wrap the whole of parse next, which at the moment parse next is kind of finding an expression. So we need parse next to say, find me an expression, and then if there's a semicolon, wrap it in a statement. So this thing is going to get wrapped up in some kind of, this code is parse expression, and parse next is going to be like maybe parse statement, something like that. So quite a bit of work to do next video to start making our parser look like an actual parser, which can backtrack, which is what this pushing back thing is, and also can tell the difference between an expression and a statement, I guess. All right, I hope I didn't completely throw you off with that. It might become clearer next time. In the meantime, I hope you're enjoying. Really wish you well. Have a fantastic day today, and see you soon.